Okay, let's say that morning you wake up at 5 a.m. Let's say 5 a.m. Okay, and the time flies by. 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 a.m. When time increases, what would be the ambient temperature, the outside temperature? Will it increase or decrease? Quickly, let's see. It will increase. So, I would say the time and temperature is correlated. If it is clear, type super clear in the chat box. The time and temperature is correlated. All right. So, how are they correlated? If the temperature increases, the time also increases. No, sorry, the other way around. If the time increases, the temperature also increases. So, it is called positive correlation. Positive correlation. All of you type plus and VE in the chat box. Positive correlation. Suppose after lunch, after you have lunch, you're going towards the evening, 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m. Okay? As the time increases, what happens to the temperature after lunchtime? What happens to temperature? Decreases. So as the time increases, the temperature decreases. So it is called negatively correlated. Type minus VE in the chat box. Minus VE in the chat box. Okay. Now the question is there a correlation between? There is a correlation between the time and temperature. But now my question to you is there a correlation between the time of the day and your mood? Type yes or no in the chat box. Let's see. Is there a correlation between the time of the day and your mood? Tell me whether it is positively correlated or negatively correlated, or it's not correlated. It depends on some other factors. It's not depends on time, but it depends upon some other factors. Okay, it depends upon some other factors. Okay. So I hope you're finding these discussions interesting, useful, valuable, fantastic, awesome. Put it in the chat box if you're enjoying these discussions. What I want to communicate to you is correlation is a relationship between two variables. And when you try to find out that relationship in the form of a mathematical equation, it is called as regression. So correlation is the strength of the relationship between two variables. And if you try to find out the equation of that relationship, it is called regression. If this is clear on a scale of 1 to 10, you give me a 9 or 10 if it is super, super clear. So this is a measure of the relationship between two numeric variables. And this is how the two numeric variables affect each other. In what direction that is it go? Fantastic. Okay. So whatever that I shared, let me quickly summarize here. Correlation and regression are statistical concepts that help Six Sigma teams understand whether the two factors within the process are related. You can use these tools to calculate whether the input is related to the output in some way, or even whether the two inputs or outputs may be related at all. The concept of correlation regression was already discussed in earlier chapter. If you want access to those videos, you can. I'm going to post that in the Telegram group. So be a part of the Telegram group. Okay. So we will talk about the relationship between two variables. We will talk about correlation coefficient, and then we will get into strength of different types of correlations that are there. Okay. Now, what is correlation? Let me go into the depth of it. So we said that correlation is between the relationship between two variables. It can be strong relationship, weak relationship, or no relationship. Right? So that's why we call it as a positive correlation, negative correlation. Or sometimes it might be a coincidence that there is a relationship. Sometimes it can be a coincidence that there is a relationship. Let's say in the city of New York. Okay, let's take the city of New York. And in 2000, I'm just giving a hypothetical numbers, okay? In 2015, there were 100 churches. In 2016, there were 105 churches. And 2017, 18, 19, every year there was an increase of 5 churches. Okay, 100, 105, 110, 115, 120, likewise, every year the churches, number of churches are increasing. Parallelly, we found the number of bars in New York. Okay, weekend parties where you go for bars, right? And we found that there were 200 bars in 2015, and every year there are some 10 bars increasing or 5 bars increasing. 205, 210, 200. If you plot the variable for 2015, 100 churches, 200 bars. 2016, 105 churches, 205 bars. So there will be a positive correlation. How many of you understood this? Type you yes, understood in the chat box. If you draw a relationship between the number of churches over the period of 10 years and number of bars over the period of 10 years, both of them are increasing. So does that mean they are positively correlated? Does that mean if you increase the number of churches, the number of bars will increase? Or does that mean that if you increase the number of bars, the number of churches will increase? Is there a relationship? Okay, type a big no in the chat box. Type a big no in the chat box, because in this case, correlation does not mean causation. Okay, correlation does not mean causation. If this concept is clear, type super clear in the chat box. Because sometimes you will see the relationship, but do not, if apples are also growing, oranges are also growing, that means that if more apples are growing, more oranges will grow. No. Okay, these are all some factors for their growth. They are not related to each other. Thank you very much. So I want to drive a point where correlation does not mean causation. Okay, coming back here. If you see the temperature over time, there is a strong positive correlation, and you can also draw it, but you can draw a trend by this line here. Okay, so this is positively correlated. The relationship is strong because when you draw a line, when the points are closer to the line, it means it is a, if the line is showing an upward trend, and if the points are closer to the line, it means it is a strong correlation. Let me look at the other graph where, with respect to time, the temperature is decreasing. Okay, so it means that if it is decreasing, it is negatively correlated. And if the points are closer to the line, it means it is strong negative correlation. Okay, I'm not reading the complete text on the left side, but I have given you enough explanation verbally. Now, this is a weak positive correlation because there is a positive correlation, that is, the line is increasing, trend of the line. Okay, but the points are not closer. That means it is weak correlation. Sometimes what happens, the line is just flat, okay, and the points are also scattered around that far. That means there is no correlation. So we have different types of correlation: strong correlation, weak correlation, maybe strong positive correlation, weak, strong negative correlation, weak positive correlation, weak negative correlation, and moderate correlation and no correlation at all. So now if the correlation concepts are clear, I wanted to give me on a scale of 1 to 10, a 9 or 10, if this concept of different types of correlations are very clear with you. Give me a 9 or 10 if you're super clear about the concepts of different. All right, now what I'm going to do is, I'm going to talk about something called as correlation coefficient. Okay, correlation coefficient. Correlation coefficient is actually a number which will tell you the strength of the relationship. A number that will tell you the strength of the relationship. I will start with 0. All of you type 0 in the chat box and say no correlation. 0-NC. 0 means no correlation. Okay. From 0, if you go to 1, 1 means very strong positive correlation. So all of you type 0 hyphen NC, no correlation. Okay. Now, if you go from 0 to 1, 1 means all of you type 1 hyphen SPC, strong positive correlation. Okay. Strong positive correlation. From 0, if you go to minus 1 hyphen SNC, strong negative correlation. Strong negative correlation. All right. So this is represented by a value, which is, and this value, which is minus 1 to plus 1. Minus 1 being very strongly and negatively correlated, plus 1 being very strong and positively correlated. And when you come to the center, which is closer to 0, there is no correlation. When it is minus 0.5 and plus 0.5, it is moderately, either weakly correlated. Okay. So if this is clear, all of you give me a 9 or 10. If it is super clear, and what I'm going to do here is, okay, this is what is a correlation? It's a number that is used to describe the strength of the relationship between two variables, ranges from plus 1 to minus 1. And I have explained that what is moderate, what is positive, what is negative, and all that stuff. Now, let me get into now these things. So I also said correlation coefficient is between minus 1 and plus 1. So what I want to do quickly is, friends, I want to give you a formula which will scare you. Okay, I want all of you to get scared. Okay. So this is a formula. God's sake, don't remember this formula. Okay. God's sake, don't remember this formula. All of you say, give me a thumbs up. Yeah. God's sake, don't remember this formula. Okay. Because Excel will give you this correlation coefficient. But then I want you to get a glimpse of how do you calculate this correlation coefficient with the help of a formula. Okay. All of you type escape in the chat box. Okay. You have to escape from this formula. I'll give you, Excel will come to your rescue. Okay. You can also put that emoji, somebody running away type of emoji. Knows if somebody can find out somebody running away type of emoji, you can put that escape from all this formula. Okay. Now, there are two methods to calculate in Excel. I will show you the method, and it is based on this formula. There was this statistician called Pearson. It was named after him. It's called Pearson coefficient correlation. Okay. Deep breath and good. That's a nice emoji. That I love emojis. Okay. And so we will practice this. Okay. So the formula is shown here. I just wanted to have a glimpse of this formula. I'll give you this presentation inside our Telegram group, but don't worry, we will exactly find out how to calculate this, okay? Okay, now if you see here, it is written something like this, okay? A set of two variables, okay? Month on the job, 2 months on the job, 3 months on the job, 4 months on the job, 5 months on the job, and average production, all that stuff. Now, here I'm going to share with you a practical case study, okay, of let's say some different temperature, different ambient temperatures with respect to time. Let's say in the factory, there are different rooms, okay, or different halls, and each of the hall temperature is different because of the air conditioning or whatever it is, okay. Let's say this is a temperature of room A, room B, room C, and room D, okay, different temperatures, temperature A, B, C, D. Room A, B, C, D. Okay. Now, I wanted to directly take you to Excel, and instead of PowerPoint, I wanted to practically show it in the Excel sheet. How many of you are ready? How many of you are excited? Just put it in the chat box that you are excited. Okay. And I'm going to share with you the Excel sheet. Okay, excited? Very good. Let me quickly share with you the Excel. Okay, where is the Excel? Let it open the Excel. Yeah, Excel is opening. Very exciting. Okay, very good. Thank you very much. I really need excitement from people, okay? That's very important. I need people who are excited. Okay, I've opened an Excel, okay? And okay, now in this Excel sheet, I'm going to copy this, whatever that is there in the presentation. You can, in the presentation, you see this temperature A, B, C, D, okay? Okay, this numbers, I'm going to copy inside this Excel sheet. Okay, just hold on. Let me just copy. I've already have the detail here. Let me copy from here. Okay, there it is. All right, that's great. So we have the time here. So temperature in this room, let's say that this is of this color. This is the room. This is room number 2 temperature. Okay, let me put a different color. And this is temperature C of a different room. Let me highlight with a different color. Okay, and this is temperature D of different room. We'll highlight with a green color. Okay, so far, if you're with me, type WU with you in the chat box. Okay, and now we are going to calculate the correlation and regression here. First, we'll talk about correlation. Okay, so you are with me here. Okay, now I'm going to reduce this a bit so that you can see the graphs. Okay, all right, fantastic. Okay, now what I'm going to do here is I'm going to just view, I'll remove the grid line so that you see a piece of this thing here. The first thing that you have to do is just see direction of relationship. Okay, so we use scatter plots. All of you type SP in the chat box for scatter plots. I will tell you how to calculate the scatter plot, how to do the scatter plot in Excel. Okay, let me help you do the scatter plot in Excel. Great. Okay. Fantastic. Thank you very much. The first thing we do is I'm going to find out between the scatter plot between time and temperature A. So I use a time which is 1 a.m., 2 a.m., 3 a.m., 4 a.m. up to 12 a.m. Okay, 12 p.m. Okay. So from or whatever it is, the time. Okay, the time is 1 to 12, and then the temperature is temperature A. So I'm going to go to insert, and under insert, there is this scatter plot. Okay, there is a scatter here, and I'm going to click the scatter, and I see a graph here. So what I'm going to do is I'm going to delete this graph. I'm going to include the time and temperature also so that I get temp A on the top. So I'm going to go to insert. I'm going to put this click and scatter plot here. So I got temperature A. So this is time versus temperature A. If this is clear, all of you type super clear in the chat box. SC, super clear in the chat box. All right. So can I do the same thing as you are typing super clear? I'm going to take up this temperature and draw all the other charts also with respect to temperature B also. Okay. So please keep watching my steps. I've chosen time and temperature B. I'm going to insert. I'm going to click the scatter and XY scatter. I'm going to click on this. I've got temperature B, time versus temperature B. Okay. Now I'm going to go the time versus temperature C and time versus temperature D. So again, I click the time here. And I'm going to choose temperature C here, the time versus temperature C. I'm going to go to insert. I'm going to click the scatter plot. I'm going to click this so that I get a time, I'm sorry, I get time versus temperature C. Okay. Now that I've got time versus temperature C, allow me to just decrease the font a bit because I can show all the four graphs. Now I'm going to put time versus temperature D, the room D. Okay. And then I'm going to go to insert and scatter plots. And now we have all the four times clearly written here. Okay, I think I've clicked something else. Let me delete this, some other graph I have done. Okay, I've put this time here and choose the temperature here, D here, go to insert, go to scatter plot, click on the plot here and come here and add it here. I'll just raise this a bit so that it looks a different graph, okay? It looks nice and different, okay? So far, if it is, I'll increase this a bit also. I'll increase the wait. Okay, I'll slightly increase this so that you can see. Yeah, that's right. So far, if you are with me, so far, if it is clear, give me a 9 or 10 if everything is super clear. I have done 4 scatter plots in front of you. I've done 4 scatter plots in front of you. Now, the next step is correlation coefficient. All of you have seen in the chat box. Let us do this correlation coefficient, and I'll give you the formula here. Okay. Right. So, is equal to CORRL. Okay. I'm going to give you the formula here. Is equal to CORRL. First, the correlation between the temperature and, the time and the temperature A. And what is the number that you see here? Okay, let me just increase this number for you. Okay, what is the number that you see here? All of you type in the chat box. I want to make sure that you're able to see this number. 0.981, fantastic, okay? This is correlation between time and temperature A. So what does it mean? It means it is towards 1, so strong positive correlation. All of you type SPC in the chat box, strong positive correlation. And I'm going to do the same thing here, is equal to correlation between the time, I choose the time, comma, I'm going to do the temperature B, and I'm going to hit the enter, and I'm going to give the same format here. And what is the number that you see? Please put it in the, whatever number that you see, please put it in the chat box. Okay, let me have it the 3 decimal places, maybe. Okay, let me also have this as 3 decimal places so that you're not overly confused. Okay, and similarly, I'm going to give the correlation of this particular thing is equal to correlation of the time, okay, comma, temperature C, and enter. And once I enter this, please let me know what is the number that you see and what you infer from this. What you infer from this. And the last graph correlation is equal to correlation of the time versus the temperature, comma, the temperature D, and enter. And what is your inference from this number? From this number. Okay, let me put the format here and put it here. So 0.861. So 0.1 is no correlation, okay? 0.1 is no correlation, 0.86 is moderate. It is going towards moderate. 0.9 and 0.99, 0.98 is very strong positive correlation. If this was clear, if this was useful, this was fantastic, if this was awesome, please give me inspiration, put it in the chat box. I'm going to tell you method 2, the another method for this, okay? The another method is you can go to data, okay, and data analysis toolpath. I want you to pick up correlation here and click OK. And click OK. So I'll just hold on to the chat for some time. Please hold on to the chat box here. Okay. So that we can focus on what I'm doing. Please focus on what I'm doing. Don't miss the bus. Input range. I wanted you to type all this as input range, all the 4 as input range. Okay. So if this is clear, all of you type super clear in the chat box. Input range, I want time and all these temperatures to come in. Okay. I started from A to E13. I've selected everything. And output range, I'm going to give it here. Okay. Output range, I'm going to give it here. Okay. And I'm going to click OK here. And what I see here is something interesting. Okay. What I will see here is something interesting. Just hold on. Okay. If you see here, this column 1, I will highlight column 1 for you. And I will make it as the column 1 as 3 decimal places. Okay. And I will delete this. And if you see the 4, this thing, I will increase this for you. Sorry, increase this for you. And if you see this, the 4 1, the column 1 is nothing but temperature. Time here is time. Column 1 is nothing but time. This is temperature A, temperature M, temperature B. Okay. Okay, this is TMPC and this is TEMPD. So at one shot, you've got 0.981 minus 0.990 minus all that. If you can see this type ICS, I can see here, instead of doing all this one by one correlation, you can straight away put the correlation for this. And this is the second method of deriving correlation. Okay. All right. If so far you're finding it interesting, useful, valuable, fantastic, awesome, put it in the chat box. Let me go back to the presentation. Okay. And I'll quickly give you in the presentation the recap of what we had seen here. Okay. Superb. Now, the table that we had, this is a quick recall that I put slide by slide, screenshot by screenshot inside the PowerPoint so that you can do a recap. Okay. So I had this temperature A, B, C here. We had done the correlation of temperature A. We have taken this table. We had put up is equal to CO formula. Okay. After we had taken this CO formula, we had chosen the time and the temperature. We had chosen the time and temperature, and the end result appeared as 0.981. So we concluded this was strong positive correlation. Then we did the same thing for the others also. Okay. So that is called correlation coefficient. Okay. It is given by this formula, as I said, and we also see that, something was 0.1107 also. Okay, so we also used data analysis tool pack to do this, and we have chosen from data analysis tool pack, and we have chosen correlation from data analysis tool pack. And okay, here I have given here as a new worksheet, but I put it in the same worksheet because I wanted to show you the same numbers that you have seen in the correlation. And that's why I put in the same, but here in the demonstration, I put it as a new worksheet. Whichever way that you do it, it is absolutely fine. But you will notice that you will get the same numbers here. So these are the two methods. Method by using the correlation formula, or you can use the data analysis tool pack and use the correlation feature there. Okay, so the same thing you can do for temperature 1, temperature 2, temperature 3. We did for all the temperatures together, and I've shown here. And so this is the conclusion about the data analysis tool pack. And now for question and answer sessions. Okay, how many of you are ready for question and answer sessions? Type ready in the chat box. If you're super ready, type super ready. We'll have 5 questions, and I'm starting question number 1 of 5 here. This is question number 1 of 5. What does the correlation coefficient of 0 indicate? Please quickly put in the chat box even before that. Strong positive correlation, strong negative correlation, no correlation between variables, strong negative correlations. Yeah, no correlation is the correct answer because correlation coefficient 0 means there is no linear relationship. Great. All right. So the next question is question number 2 of 5. Okay. Question number 2 of 5. Which of the following statement is true regarding correlation and causation? Strong correlation always implies causation. Weak correlation proves causal relationship. No correlation means there must be causation. Correlation does not imply causation. So which one is the right answer? Put it in the chat box. D is what most of the people see. Let's see the right answer. The D is the right answer. You are done. So we have completed 2 questions. There are 3 more questions to go. You can read the explanation in the presentation that I'll be sharing in the group. Okay. The third question is simple. What is the typical range of values for the correlation coefficient? Come on, this is the easiest of question. Even before knowing the answer, you're supposed to know. -1 to +1. Oh, fantastic. So B is the right answer. -1 to +1. Okay, so we have completed 3 questions. 2 more questions. Let's go. In Excel, which is the formula used to quickly calculate the correlation? I just explained the formula. I've just related. Is equal to CORREL. That is the right, not CORR. Okay, Nicola, please correct yourself. Okay. So the correct answer is C, which is correl. Okay, CORREL, correl. That's the right answer. And let's go to the last question, which is very simple. What does a strong negative correlation explain in a scatter diagram? What does the strong negative correlation explain? Both variables increase. One variable increases, the other decreases. The variables have no relationship. Both variables decrease together. So one variable increases, the other variable decreases. All right.